So now, last time we talked about exponential equations and functions because we needed them in order to introduce what's called a logarithmic equation or function. So logarithms, by definition, are just another way of writing an exponential, and we use them to actually find the exponent that you would raise something to. So for this case, you'll notice it's y equals b to the x. In order to rewrite it, you would do log base, whatever the base was originally. So log base b, so that's how you'd say it, of y. So this is called the argument, because I'll start using that terminology a little bit, is equal to whatever the original exponent is. So logs are always equal to exponents. Now, there are a couple important notes. B does have to be greater than 0. You never have a negative base. And that's because if you had a negative base, it actually switches if it's positive or negative. So we just, like if you raise it to an even power, it's positive. If you raise it to an odd power, it's negative. So on. We just don't deal with those. We also don't want a base of 1 because 1 to any power is always 1. So even 1 to the 100th power is 1. So it is pointless. We don't use it. Now, when you're actually solving a logarithm, and I'll explain this later, you always ask b to what power, or like whatever the base is, to what power equals y, equals the argument. That'll make more sense when I show some examples. Before we do that, though, there are two special types of logs. There's one called the common log. Common log is written without a base. It's always implied, if there's no base, that it's base 10. Natural log is written as an ln, so it doesn't even have log in it. And it's always implied, if you see ln, that it's base e, my favorite base, if you remember from last time. So those are the two special logs that will come up. So we're going to first figure out how to evaluate. It's actually pretty easy. So what you're doing in order to evaluate, because we're trying to find an exponent, you're asking yourself 4, because that's the base, 4 to what power is equal to 16? Well, hopefully you know that's 2. 4 squared is 16. So that would be our answer. So for this next one, I'm asking myself 3 to what power, because that's my base, is equal to 1 over 81? Well, I know 3 to the 4th power is 81. So that means it has to be negative 4 since we've got the fraction. Hopefully this is making sense. So for the next one, you're asking the base is 5. So 5 to what power gives me 125? Well, 5 squared is 25. So 5 to the 3rd would give me 125. The next one, you're asking yourself 7 to what power is equal to 1 over 49? Well, once again, fractions tell us it's a negative number, and 7 squared is 49, so it'd be negative 2. Last one that you're going to ask yourself is 2 to what power is negative 32? Now, if you think about this one, 2 to the positive 5 gives you a positive 32. 2 to the negative 5th power gives you a 1 over 32. And if you think about the graph of an exponential, or 2 to the x, y equals 2 to the x will look like this. So you'd have no negative y values, meaning this actually is not, it's undefined. That's the word I'm looking for. It's undefined. It's not solvable. There's no solution to this. You can't do it. Okay, so you never have a negative argument. That's actually a big no-no. So no negative bases and no negative arguments. But you can have a negative answer because that's the exponent.